Welcome back to KrossUSA channel. Today, we're taking you inside 6 remarkable facilities where traditional craftsmanship meets cutting-edge technology. You're about to see manufacturing processes that have shaped our world for generations and continue to build our future. Let's get started. Welcome to the remarkable world of July BAMBU, where ancient bamboo meets modern manufacturing ingenuity. Their journey began in Hangzhou before relocating to Fujian, positioning themselves right in the center of China's bamboo manufacturing hub. NTHE manufacturing process is fascinating. First, harvested bamboo poles are cut into manageable sections and fed through powerful stripping machines that remove both the green outer skin and the yellow inner layer, revealing the strong fibers within. These strips then pass through precision saws, equipped with multiple sharp blades that cut them into uniform splints in a single stroke. Next comes a crucial soaking process where the bamboo strips are immersed in dilute phosphoric acid or ammonium phosphate solution, treating them against burn and improving durability. After treatment, the strips enter massive rotating drums for drying, bringing moisture content down to precisely 6 to 9%. Now here's where craftsmanship meets technology. Workers carefully select and grade strips, eliminating defects and sorting by color. The approved strips move to high-temperature steaming chambers where they're carbonized at temperatures between 100 and 110 degrees Celsius. This process not only deepens the color to that beautiful amber tone many of you remember from mid-century furniture, but it also removes sugars that could attract insects. NTHE final magic happens in the pressing stage. Strips are coated with formaldehyde-free adhesive and carefully arranged in alternating grain patterns, just like plywood. Multiple layers are pressed together under tremendous heat and pressure for 10 to 12 minutes per section. Bamboo plywood that's actually stronger than many traditional hardwoods, with exceptional dimensional stability that won't warp or twist like wood often does. It's sustainable manufacturing at its finest, producing beautiful, durable panels for everything from countertops to furniture, all while forests continue to thrive. Now let's journey to the heart of engineered wood innovation with IMAL Group, an Italian manufacturing powerhouse that's been revolutionizing the wood panel industry for over half a century. Based in San Damaso, Italy, this company doesn't just make machinery, they engineer complete production systems that transform raw timber into OSB, or oriented strand board, a material that's become the backbone of modern construction. Let's walk through the remarkable process. It begins in the log yard, where debarking machines rotate logs against spinning blades, stripping away outer bark while leaving the valuable wood underneath pristine. From there, logs move to Globus disc stranders, massive machines with 48 or more knives arranged in a circular pattern. As logs feed against these rotating discs, they're sliced into thin strands, typically 100 millimeters long and less than a millimeter thick. Here's where IMAL's innovation really shines. IMAL developed belt dryer technology that uses lower temperatures, around 100 degrees Celsius, powered by waste heat from the facility's biomass energy plant. Strands travel on conveyor belts through long drying chambers, gently reducing moisture to just 1 to 2% without the thermal damage you'd see in older systems. This preserves fiber strength while dramatically reducing fire risk and VOC emissions. After drying, strands move to the blending station where IMAL's high-jet resonation system goes to work. This high-pressure technology atomizes adhesive into an ultrafine mist that coats every strand uniformly while using less resin than traditional methods. Now comes the forming process. Strands are carefully oriented in 3 distinct layers. The top and bottom layers align parallel to the panel's length, providing strength in that direction. The core layer runs perpendicular, giving cross-directional stability. Picture the plies in plywood, but instead of continuous sheets, you've got millions of aligned strands creating that same structural principle. These formed mats then enter the continuous press, IMAL's crowning achievement. These massive machines stretch 30 meters or more, with heated platens that compress the mat while curing the resin. The Dynasteam preheating system uses steam injection to raise the mat's temperature before it enters the press, speeding production while ensuring even curing throughout the panel's thickness. Temperatures reach around 200 degrees Celsius under pressures of 3 to 4 megapascals. What emerges is remarkable: continuous ribbon of OSB that's then precisely cut to 4by 8-foot panels or custom sizes. These panels match or exceed the structural properties of plywood at a fraction of the cost, using resources more efficiently. Imagine building a house like you once built with Lincoln logs as a kid. That's the genius behind Brikawood International, a French innovation that's making sustainable home building accessible to everyone. Created by engineer Alain Romero and commercial lawyer Patricia Dutroux, this system took 10 difficult years to perfect. But the result is revolutionary. Each Brikawood brick consists of 4 precision-machined Douglas Fir elements, 2 lateral flanges and 2 transverse spacers, all cut with dovetail joints that interlock without a single nail, screw, or drop of glue. When these bricks stack together, they create load-bearing walls with exceptional rigidity through what engineers call the mass effect. The structure literally tightens and strengthens itself. NTHE assembly process is remarkably simple. For smaller homes under 50 square meters, owners can build it themselves with basic tools and a rubber mallet. Larger structures require trained Brikawood teams, but even a 120 square meter home goes up in just 15 days. Each kit arrives with numbered bricks and detailed assembly plans. It's truly construction made accessible. Let's talk about one of the most remarkable sustainable building materials you've probably never heard of, EcoCocon's prefabricated straw panels. Founded by Lithuanian civil engineers in 2008, this company has transformed an ancient building material into a cutting-edge construction system that's capturing carbon with every home they help build. EcoCocon panels are structural wall assemblies that contain all 4 control layers needed for a high-performance home: rain control, air control, vapor control, and thermal insulation. And they do it using 98% natural renewable materials. NTHE manufacturing process is precision work done in controlled factory conditions. It starts with FSC certified timber framing, carefully milled to exact specifications. Workers then use specialized pressing technology to compress straw into these wooden frames. This isn't loose straw folks might remember from old barns. Here's what makes this revolutionary. That straw came from agricultural fields where it was essentially waste material. Now it's sequestering carbon, about 20 pounds per square foot of wall. While traditional insulation like fiberglass has high embodied carbon from manufacturing, straw panels are actively storing carbon that was pulled from the atmosphere as the grain grew. It's like building your house out of solidified sunshine. NTHE panel system includes several sophisticated layers. The structural twin-stud timber frame provides load-bearing capacity. The compressed straw core delivers thermal performance. An exterior wood fiber layer adds additional insulation and weather protection. And here's the brilliant part. The system includes a high-performance polymer membrane that's airtight yet vapor-permeable. It stops air infiltration completely while allowing moisture vapor to escape, preventing the condensation problems that plague modern sealed buildings. And every panel is custom manufactured to 1 millimeter precision using computerized cutting equipment. They arrive at the construction site numbered, with detailed assembly plans that require only basic carpentry tools. Ground floor walls for a modest house go up in 2 days. A 3-bedroom, 2-story home can be weather-tight in 5 to 7 days. NTHE thermal performance is outstanding. When EcoCocon panels are combined with interior clay plaster, which naturally regulates humidity, they achieve U values of 0.110 watts per square meter Kelvin. That's better than most conventional walls achieve with foam insulation, and it's done with materials you could literally compost at the end of the building's life. And fire resistance might surprise you. Those compressed straw panels are certified to withstand over 120 minutes of fire when rendered. That's better than many wood frame buildings achieve. The compression eliminates air gaps, so there's nothing to fuel flames. The panels have passed rigorous testing and earned certifications, including cradle-to-cradle recognition and German Passivhaus Institute approval. Fire, humanity's oldest tool, still begins with a simple wooden match. At Asia Match in Sivakasi, India, this seemingly simple product has been crafted with precision for over 70 years. Let's follow a matchstick's journey. Debarked logs enter the peeler, a massive machine that rotates the log against a sharp blade, peeling off a continuous veneer sheet about 0.1 inches thick. NTHE cut matchsticks then go into large vats filled with dilute ammonium phosphate solution, soaking for several minutes. After soaking, the matchsticks enter massive rotating drums, like industrial clothes dryers, where they tumble and dry while any rough edges are smoothed and crystallized residue is removed. And dried matchsticks are fed into hoppers that automatically align them, then transfer them to a continuous perforated belt system. First, the striking end dips into hot paraffin wax, which provides the crucial transition fuel that carries the flame from the chemical head to the wooden stick. And after wax application and drying, the matches pass through the head coating station. The base typically includes potassium chlorate as an oxidizer, combined with ground glass powder for friction sensitivity, sulfur for easy ignition, and color dyes. Meanwhile, in a separate area, matchboxes are being produced. For cardboard matches, roll paper with 0.4 mm thickness and 300 gram per square meter basis weight runs through separators that cut it to width. Specialized machines fold and glue inner boxes, then outer boxes, before setting them together. The phosphor brushing machine applies the striking surface to the box sides, a carefully formulated mixture of red phosphorus, ground glass, and adhesive that reacts with the match head chemicals to create ignition. Welcome to the ancient art of cooperage, where Tonnellery St. Martin has been crafting oak barrels for 3 generations of master coopers. This isn't just manufacturing. It's a tradition that stretches back over 2,000 years to the Gauls, who first created oak barrels in alpine villages. Today, France leads the world in barrel production, with over 150 cooperages producing 600,000 barrels annually. Tonnellery St. Martin stands among the finest, creating barrels that will shape the character of wines, whiskeys, and spirits around the globe. NTHE's story of every St. Martin barrel begins years before the cooper's hands touch the wood. It starts in France's great forests, Allier, Vosges, Nevers, Fontainebleau, and the center of France, where oak trees have been growing for 150 to 200 years. The French government owns 40% of these forested lands, including original tracts planted during the reign of Louis XIV in the 17th century. Once each year, parcels of forest are auctioned, and companies like Tonnellery St. Martin bid on the right to harvest specific stands of timber. This isn't casual tree selection, folks. Master coopers and forest experts walk these woods, examining trees for the tight, straight grain that produces the finest barrels. They're looking for Quercus petraea and Quercus robur, 2 oak species that have distinct characteristics. Quercus petraea grows more slowly, developing fine grain with aromatic compounds and lower tannins. Quercus robur grows faster with slightly coarser grain and higher tannin content. Both have their place in the cooper's art, chosen to match the winemaker's vision for their product. When selected trees are felled, the wood's journey is just beginning. Logs are transported to the marinderie, the stave mill, where they're sawn into rough billets. Here's where cooperage differs fundamentally from standard lumber production. The wood must be split, not sawn, following the natural grain. This is critical because it preserves the cellular structure that makes oak watertight. Cross-cutting those cells would create pathways for leakage and oxidation. NTHE rough staves then begin one of the most important phases, the seasoning. Stacks of oak staves are carefully arranged in open-air yards, where they'll remain for 24 to 36 months, sometimes up to 48 months for premium barrels. During this time, the wood undergoes natural transformation. Sun, rain, wind, and seasonal temperature changes work their magic. Moisture content gradually drops from over 50% down toward 15%. But it's not just drying. Chemical changes occur. Harsh tannins mellow. Aromatic compounds develop. The wood becomes more workable, while its flavoring potential becomes more refined. Now let's enter the cooperage itself, where ancient craft meets modern precision. The seasoned staves arrive at the preparation workshop. Using specialized jointers, often sophisticated machines like the R-Monot SA multi-stage jointer, one of only a handful in the world, each stave is planed and shaped. The edges must be beveled at precise angles, so that when multiple staves come together, they form a perfect circle. The middle of each stave is slightly wider than its ends, creating the barrel's characteristic bulge that adds structural strength. Here's where the master cooper's eye becomes essential. He selects staves for each barrel, examining grain patterns, color, and potential. A standard 225-liter Bordeaux barrel uses about 32 staves. Each must be positioned just right to ensure the finished barrel will be both beautiful and structurally sound. NTHE raising process is poetry in motion. The cooper arranges selected staves vertically inside a raising hoop, a temporary metal band. As he adds staves, the circle grows, each piece fitting against its neighbor, with those precisely beveled edges creating a tight seal. Once all staves are positioned, additional temporary hoops are hammered into place, holding the emerging barrel's head end together, NBUT. The staves are still straight, and we need a curved barrel. This is where fire becomes the cooper's tool. The partially assembled barrel, secured in its temporary hoops, is positioned over a small fire, traditionally wood chips or shavings, sometimes oak for its specific aromatic properties. As heat and moisture work into the wood, the cellular structure becomes pliable. The cooper begins working the open end, persuading the staves to bend inward, using winches, cables, and considerable skill built over years of practice. This bending process takes time and patience. Too fast and the wood might crack. Too little heat and it won't bend sufficiently. The cooper monitors the wood's temperature and responsiveness, adding or reducing heat as needed. Gradually, the staves arc inward until they can be secured with another temporary hoop at the belly end. The barrel now has its basic shape, the two ends of equal diameter with that graceful curve in between. NBUT, we're far from finished. Now comes toasting, perhaps the most critical phase for flavor development. The barrel is repositioned over a more controlled fire, and this is where real artistry emerges. Different toast levels create dramatically different flavor profiles. A light toast might last 15 to 20 minutes at controlled temperature around 180 degrees Fahrenheit, developing subtle vanilla and fresh oak notes perfect for white wines or delicate spirits. Medium toast extends to 30 to 40 minutes, building caramel and toffee notes. Heavy toast can continue for an hour or more, creating intense smoky, spicy, and even chocolate characteristics. NTHE Master Cooper controls this process with incredible precision. He's monitoring temperature using both instruments and his trained senses. The smell of the toasting wood, the appearance of the surface, even the sound as the wood changes. At Tuileries St. Martin, where barrels might be destined for $275 per bottle Cabernet Sauvignon programs, this precision is absolutely critical. A blonde toast, their lightest level, requires exact temperature control over exact time to achieve the winemaker's specifications. After toasting comes one of the most specialized operations, the crows. A cooper uses this dedicated tool to cut a groove near each end of the barrel's interior. These grooves, typically about half an inch from the ends, will receive the barrel heads. The crows must be perfectly positioned and uniformly deep all the way around. Too shallow and the heads won't seat properly. Too deep and you weaken the stave. Now we can prepare the barrel heads. These circular ends are assembled from several pieces of oak, carefully selected and edge-joined. The heads are often made from different oak than the barrel body, chosen for specific characteristics. Each head receives the cooper's brand, the cooperage logo, the year of manufacture, and specifications that tell the complete story of that barrel: which forest, what toast level, how many months of seasoning. With the crows cut and heads prepared, the temporary hoops come off and permanent steel hoops take their place. At Tuileries St. Martin, these might be standard galvanized steel, or for special orders, blue steel, or even decorative finishes. The hoops are driven into position using hammers and considerable force, compressing the staves tightly together. This is where the barrel becomes truly watertight. The pressure from those hoops forces the staves so tightly together that no seal or adhesive is needed. NTHE heads are positioned in their grooves, and reeds, thin strips of flexible material, are carefully inserted between the head and the groove to ensure a perfect seal. Everything is checked, double-checked, and refined. Now comes finishing work that transforms a functional container into a thing of beauty. The exterior is sanded smooth, bringing out the gorgeous grain patterns of that carefully selected oak. Multiple rounds of sanding with progressively finer grits create a furniture-quality finish. The hoops are cleaned and polished. For some barrels, especially those with decorative specifications, wooden chestnut hoops are added at the ends, wrapped and finished with wicker, a beautiful traditional touch that harkens back centuries. NTHE bunghole receives special attention too. This opening, through which the barrel will be filled and sampled, is positioned precisely in the center of one of the staves. It's cauterized with flame to create a tight seal around the wooden or silicone bung that will close it. Before shipping, barrels enter a climate-controlled storage area where they're kept at proper humidity to prevent the wood from drying excessively. They're often shrink-wrapped for protection during transport. From Tuileries St. Martin's facility, these barrels will travel to wineries and distilleries worldwide: California, Australia, Chile, South Africa, throughout Europe, and beyond. This is craft manufacturing at its absolute finest, honoring the material, respecting tradition, embracing appropriate technology, while keeping human skill and judgment at the center. Every barrel that leaves Tuileries St. Martin represents countless hours of labor, years of material preparation, centuries of accumulated knowledge, and a commitment to quality that defines French cooperage.